live coverage here in Nuremberg, Germany. Let's start day one, first video. I'm gonna connect right now. Like this. So, guys watching, let me know if there's some drop frames. Oh, I see there's a bunch of drop frames. I think it means that I need to pause this for a second. I'm just gonna turn off this Wi-Fi. Okay, we are resuming now. Let's try to make sure that the quality is good. Okay. You be okay to be on the video?
Yes.
Yep. Okay. Cool. Let me know. Are we good now? Oh, you speak? Okay. Cool. Okay, let's go. Please. Let's start over here. Yeah.
How should I do? How should I do?
Hey, seed. I'll check out the seed just after. Okay, so please. Okay, come a bit closer to me. Okay. I'll come close to you and I'll ask you questions and you can introduce yourself and say, welcome to the Murata here, the better world. Okay, let's try. Okay. And then you show the coolest stuff. And, let's say I film this. It would be good if you come close to the microphone to speak, not too far away, yeah? Because the microphone is straight ahead. Okay? Okay, let's try.
Can I confirm your question before the?
What do you say?
Yeah, can I?
Like this. What is the coolest, the most important new product? And it's cool to show it close to the camera. Yeah, let's try it. Right.
Oh, that's nice. It looks good.
Okay.
Is it behind the glass? It's not possible to take it out?
Thanks.
To show it like this? No?
Where is the watch, I guess?
No. Yeah, it's not.
Yeah, maybe.
Okay, let's try.
Yeah.
You okay to be?
Yeah.
Yeah, okay. Let's start like this. Okay, 1 second. Hi.
Hi.
Please introduce yourself.
I'm Nozomi Kishia, working at Murata.
And what is the coolest new technology here, the embedded world?
Okay. We have a 6 GHz radar module, which is the very smallest and high performance radar module.
Can we see it?
Okay, of course.
So it's a module that does what?
Sorry.
Let me try to get close to it.
Yeah.
So, what does it do?
This is our radar module, left side.
There,
yeah. Yeah, left side.
60 gigahertz.
Yeah, 6 GHz radar module.
And 60 gigahertz is useful for what kind of radio? On all the IoT kind of devices?
Yeah, this is an evaluation board to easy evaluate about the function.
And it will go in the car? Where will it go?
Yeah, left.
Those all the applications?
Yeah, we have several target applications. One is in-cabin sensing and out-cabin sensing for the parking assist and the automated door and the security and the automotive lawnmower and so on. Many applications.
Nice. That's cool. And what else is cool here to show?
Yeah.
What else you can show? You can show it? Some other
sorry.
guy?
Yeah.
I'm not in charge of other product.
Okay. Okay, thank you.
Thank you.
Let's go around here.
Yeah.
Okay,
Let's
I'll follow
see
you.
like the most interesting demo we show.
Yeah.
Yes.
Hi.
Hi.
Hello. What do you show here?
Okay. What should I do at first? Okay.
What is this?
This is our Murata's AI module. This module is using a Google chipset. It's called Coral. We are using Murata module for this demo. It's showing human detection. It's showing our arm and our leg and our head. So it track our body parts like this one, like this one.
And this is
track
just
the leg.
this is computer vision. This is just with a camera
Yes.
and analyze very quick.
Yes, right. Perfect.
And where is the board to do this?
Yes, here. This one is our product.
You call it the Coral?
Yes. It's called Coral, and it's based on Google chipset.
Google.
Yes.
Well, you work together with Google to make this?
Yes.
It says the Coral Edge TPU 1WV CATEC Award.
Yes.
4 tops. It's a high performance, low power. Is it ARM? Is it ARM CPU?
Not ARM CPU. It's using the CPU from Google. It's called the Coral.
All right. So it's a different kind of architecture.
Yes.
Nice. Here's this also.
Yes, it's a real module of Coral.
What's the price?
Price, it depends on the quantity, but around $20.
$20.
Yes, and we can buy this module from a website of Google.
Oh wow.
And we have
It's mass production already.
Yes, and we have some type of evaluation board like this one, and not this one. We have like this one and like this one.
What's happened when people do the QR code? They can get a free board?
Not the free board. Unfortunately, it's
More
not free.
information, yeah?
But we can access the website of this board.
Nice. And there's more information here.
Yes. The
And this is
performance.
performance?
Yes.
How high is it? Very high.
The core module is
102 times faster than V4? Or depends what you do, right?
just
But it's very powerful.
It's
And
yes.
and then you partner with these with the camera and
Yes, you're right. They are the partner of they are the customer who is using a Coral module for camera. So now we have now there are 3 customers. They are using a camera, and on the website of Google, you can see more customer who is using a Coral module.
nice. What else is cool here at the booth? What else I should check? What is the coolest demo?
Coolest demo. I think this demo is very
Can
nice.
you speak about this?
Yes, it's no problem.
Yeah. What is this?
It's a demo for our Ultra-wideband module.
Yeah.
Okay.
And is it this?
This is the evaluation board of our module. Our module is this one.
What's the name of this?
It's Type 2 AB. This module is based on Corobot chipset, and this module is using Nordic IC. It's included over this modules. And,
Nice. That's cool.
With this demo, we are using some evaluation board for this. One is a tag, like this one. It's including Type 2AB modules.
What is it? Type 2 AB. How does it connect? What does it do?
In this one, it's working with coin battery, and this board have Type 2 AB module.
And Murata make the batteries? Many batteries?
This battery is made by Murata.
Yeah.
And this side is anchor side is also using Type 2 AB module.
Nice.
And we are using 5 anchors for this demo. One is at here, and one is at here, and at here. And we put one anchor on the wall, like that
Oh,
one.
you have them all over the booth, and then based on that, you can do positioning.
Yes, right. We can show the position on this map. We have 2 blue points. It's showing the location of our tag.
Nice. Rotation.
Yes. If I move this tag to booth E.
Okay. That's cool.
Yes, bullet points go booth E.
It's very fast.
Yes.
And it's for all indoor application. Can it connect with mobile phones, or is not for this kind of application?
About this demo is only for indoor location, but not the use case of ultra-wideband is not only indoor location. We can use this module to check distance and to check angles, etc. So yes.
And it works with every BLE, every Bluetooth device will be compatible.
Not Bluetooth. It's including Bluetooth, but we are using ultra-wideband to check the locations.
And here I see it says hostless Nordic component for the BLE. And then, yeah, I'm trying to understand what devices will be compatible with this indoor network, with this indoor GPS, you know, kind of.
Yes, there are some technologies to check the locations. For example, one is GPS and one is Bluetooth, but the accuracy of to check distance is ultra-wideband is the best. Ultra-wideband is better than GPS and BLE, so we are using ultra-wideband for this demo.
What is over there? Cellular modules. You can speak about this?
Sorry, unfortunately,
No?
I can't.
Oh, which other one is coolest at the booth?
The cool booth. We have other demo for this
check
side, but very working. But I think it's
I can ask
better.
you a friend to be on video. Do you want to speak about this? Hi. So what are you showing here? Ultra wideband radar and ranging. There's like a part you were do together with NXP.
Yep. So based on the NXP USB IC, we have modules solution.
And what do they do?
Okay, so please see. This is
As a
range-
distance.
Yeah, range cable. Communicating with this vibration ball and this tag. You can see the real time.
Nice.
Yeah, so ranging. It's very accurate.
Wow. It's very accurate.
Yeah, it's around the plus minus.
How does it work?
Centimeter. Plus minus
How is it
centimeter.
possible to do that? Is it pinging? Is it some kind of sonar?
No,
What's
it's
happening?
a UWB signal. So communication.
Wow. And does it work in different directions or only straight in front?
Let me call Berto because Berto from me. Have you heard of that? So sorry.
Are there already applications in the market, or is brand new?
No, this evaluation ball is already in market.
How much its price?
Price is it depends on the quantity or the project.
And then people can play with it, and they can try to use it. What would be the product at the end?
The end product?
Yeah, what could be the end product for this?
It is for tag, USB tag. So it's like air tag is in already market.
So you can put this in your garage on the wall, and then you put your car exactly at 0 centimeters from the wall. Yeah? Because your garage is just limit, because you have an American car, it's a little bit too long. Something like that? Yeah, it's rebooting, huh? The Raspberry Pi, you're rebooting that one. Something. So that's cool. But I just saw it. We just saw it. Which other part of the booth do you think I should film? That's really cool. Do you have some idea? What should I film here? What's the next? Oh, okay, I'll just walk around. Okay. So that was here. Here's power. Here's stuff to do with the software. Hi. Do you want to speak about this on video? Can I make to view?
Okay.
Yeah. So What is this software here?
This is
That we
called the
see.
Femited. This is the CAE software,
Yeah.
and we can do this software, including these 8 solvers. You know, so here,
what's it's for designing?
design for application itself. Lots of applications like this.
It's very advanced, right?
Yes.
It's to calculate the heat, the thermal, mechanical,
fluid, magnetic, electric field, piezo, acoustic. All
Nice.
of the simulation.
So what is
you can
missing? Which part you don't have? Atomic. No, no need.
get. No need. No need.
So it's like everything that happens to something concrete, something real, and industrial, or
Industrial maybe. Yes.
all right.
But not military, except the military. Yeah.
Yeah,
Yeah,
it's
so
peace.
that's right.
Peace in the world. Nobody needs to measure anything to do with military.
Exactly.
And there's it looks like magnets or coils and
This is the coil, toroidal coil, and just winding.
okay,
Very
Cool.
simple design.
nice.
Yeah.
All right. Thanks a lot.
Thanks.
And here we see. Do you know if anybody can speak about this? Let's try to do some video right here with the wireless ecosystem. Hi.
Hi.
Please introduce yourself.
Hi. Okay. You can say. Okay. Hi. I'm Anders Roswald from Embedded Artists, and we are a partner to Murata.
So you make these?
Yeah. We and the green.
Where are you
ones
based?
also. We're based in Sweden.
And you make PCB design?
Yep. So we are a company that makes computer modules. So we do both computer modules and Wi-Fi and Bluetooth modules, where we use the Murata modules, and then we add PCB in the M.2 form factor.
Is it different boards or the same? What are we looking at here?
Yeah. So we have a lot of different Wi-Fi and Bluetooth options. They are in the M.2 form factor. That makes a perfect fit for evaluating the different options. You can evaluate the different modules with performance and cost and power consumption, for example.
So you have a bunch of NXP?
Exactly.
Yeah?
We only work with the i.MX family from NXP, so we are specialized in the NXP application and microcontroller processors.
Is this the powerful one?
Exactly, this is the newest one that we have just released. That's the i.MX 93. It's just a few days old, so to say.
So what is a partnership you have with the Murata? They have some different parts that go on there?
So we started out with Murata to develop the M.2 form factor to, seamless wireless integration for the i.MX family is the title of this display card. So we are working on making this really easy when you want to evaluate the Wi-Fi module for the i.MX family. We have the Linux BSP is completely ready to go. You just hit the on button and then you have the drivers and everything in place. You don't need to recompile the kernel or anything to get things started.
And your Linux is very stable?
Yeah, absolutely. We work with the latest one that NXP releases. So 3 times a year there comes, or 4 times a year, there comes the new Linux BSP.
There's been a lot of developments in the Linux for the embedded in the last few years, right?
Yeah, definitely. Yeah, we find it very stable. We haven't heard any problems from any one of our customers.
What is this board here?
So this is the evaluation platform. The black part here is the we call it the carrier board. That's a reference design for the end customer's carrier board. So you can use this as a starting point to design your own hardware.
And how do you connect? Where do you connect the stuff on these? And how does it work? What is the standard?
So on the bottom, so on the bottom side there is Hiroshi DF40C connectors. That's more or less a standard in the industry to use these connectors.
And here at the Murata booth, you're talking a lot about all the different solutions that are.
Exactly, and we have solution for the Matter protocol also. So this is a development platform based around the i.MX 8 Mini, and we have the 2EL module here that also both supports Wi-Fi, Bluetooth, and Thread. That's the three wireless technologies that is supported by the Matter.
It's very trendy, the Matter.
Yeah,
a lot of people are working with this.
Yeah, exactly. And this is a display of the three different platforms that you can use from Murata to get started immediately with your development work.
And where in Sweden are you based?
So we are based in the south of Sweden, in the Malmö region.
So just next to Copenhagen.
Exactly.
You have any Danish working in the company?
No, no, we don't. But we would love
to.
Are
you
have.
A big company?
No, we are a very small company, actually.
How many years have you been working on the embedded?
We have been in business for 23 years, actually, and we've been working very closely with both NXP and Murata for many, many years.
Nice. This is a great show, no? They're very busy.
Exactly.
Like, a lot of people coming.
Exactly. It's a real nice thing to see now after COVID also. The floor is packed, really.
Nice. That's awesome. Okay.
Thank you very much. Ja, tack. Ja, tack.
All right. Do you know of something cool here, the booth that I didn't cover? I'll need to go around.
Maybe the.
I tried these guys
the
already.
AI also
okay.
Might be.
Tack. Vi ses. Okay.
What can you show us?
And here's something about the geolocalization and the LoRa.
Logger that runs there. And I'm envisioning that we have a PCI
did you have some secrets in the meeting room you want to show? No?
Nothing secrets in the meeting room.
Okay. Okay, thanks a lot.
Yeah,
okay.
Thank you.
Okay, thank you. There we are. All right. So please wait around for 1 second. I'll be right back with the live stream. Hi. Please introduce yourself.
Hi, I'm Marcus from Caro Electronics. We develop and produce computer on
sorry,
modules.
let me start again. I didn't press record, but it's live streaming. It's live. Hi. Please introduce yourself.
Hi, I'm Marcus from Caro Electronics in Germany, Aachen. We manufacture computer on modules made in Germany. I'm from the software department. Yeah, and I can.
What's the coolest new boards you talk about here?
We have the i.MX 93 over here. These are the latest
right
one,
there?
the smallest form factor.
So that's high performance. If you can go this side. Yeah, so I get your sound right there.
Yes.
So high performance ARM Cortex A55.
A55.
Dual core.
Right. The landmark is just this small.
What is this?
This is the module. This is the form factor of the module. Everything on this board comes with processor, DRAM, flash, and
nice.
power management unit.
And what is the whole thing we see here?
This is the evaluation board you can buy as a customer to develop your first kind of software for product, and it's made to later on design your own baseboard where you just solder on this module.
How much is a module?
Yeah, module pricing is done with our sales.
Depends how many people order.
Of course.
Can be small quantity, big quantity.
Depends on quantity, but everyone is welcome to contact our sales for further information.
And is this like a RAM? What, it looks like you
Yes,
slap it in. Is that your form factor?
This is another form factor from us. We developed our own standard. This is the plug-in standard, and mostly identical pinout with the solder down standard.
Same chip?
Same chip, both i.MX 93.
So where is the i.MX? Can you point to it?
This
is that one?
This is.
And what is the other stuff?
The other stuff, we have the flash over here.
Yeah?
Yeah, I think. Sorry, I'm just a software guy. But I think Nanya was the flash.
And a bunch of other chips.
Yeah, we have the Ethernet PHY, also power management, and DRAM.
Nice.
DDR4L.
How many years Caro has been doing this kind of work?
Caro exists since in the 90s. To give you the exact year, COM producing since.
I work with ARM, work with NXP.
You see, our company exists since 1988.
Oh wow!
And yeah, we work with NXP, STM32, and also Renesas.
That was the ARM 3 in 1988. I'm joking. Okay.
Okay.
And these are Renesas, RZGL, RZG2L.
Yes. Yeah, as you can see, they also follow along the plug-in standard and also the solder down standard.
Is it cheaper to do this form factor, or it's more expensive because it's smaller? Maybe it depends.
Yeah, but
We have to
it
talk to
depends
sales, huh?
on what you need, on which form factor. Mostly price depends on components which are on there.
What kind of software do you work with?
We develop Linux. Linux compiled by Yocto with kernel bootloader. You can also have Debian on ARM64, but yeah, to talk from software side, that's not a good way to go with embedded
Why?
Linux.
Why is Debian not good way?
Let's say graphic stacked library or every hardware related stuff isn't supported very good. In
But
Debian.
Yocto has graphics. That's
Of
good,
course, Yocto
well supported.
Yeah, Yocto compiles all the libraries you need for GPU, runtime, and other stuff. So Yocto is much more customizable and much more lightweight. Because lightweight is what you need for embedded products.
And
Debian is more kind of a big blob.
It's fun, Debian.
Yeah,
but it's more difficult in the embedded
It's
world.
very easy for someone to start with Debian, but with Yocto, my opinion is you cannot go past Yocto if you want to make a real product.
And here we have ST32 MP1. That's a dual cluster with the A7 and also with a microcontroller. And Yocto is good on this? On all of them, the same?
Yes, we run our own BSP, so we extend the layers from the manufacturer of the processor and make it work for all our hardware. So you get all the features you need.
Cool. What's the latest developments that have been happening with the Yocto? A lot of advancements in the last couple of years, 3 years? A lot of things are better and better, or just basic?
Yocto is continuously growing, but Yocto itself stayed basic. What's growing is software around Yocto. Like Linux is developing very fast in the last years. I think we ran in the last 2 years from Linux 5 to Linux 6. All our modules are on Linux 5.15 at the moment, on a long-term stable version. And I think that's one of our benefits we can use for. So Yocto itself is a solid tool to configure your own embedded Linux.
How good is it this new NXP? Is it great? Like
I'm very impressed by the Cortex A55. Since it's just a dual core, it's very fast. Maybe I can show you a boot up process.
Yeah.
We can just reset it. So to tell you what's going on, it now starts the Linux kernel, then it boots into Western Wayland desktop, and then it launches an Electron Chromium-based web app, which is our demonstration application. So you see,
6 seconds.
Booted up.
7.
Yeah, and we would be able to even make this a bit faster. Like we have 1 second boot delay, where the developer could interrupt into the bootloader or something, and we could speed this up even more if you'd like to. So you saw in 6 seconds, demonstration application was up and running, and I'm
What's
very
the coolest
impressed.
stuff that your customers do? Many cool projects?
Yeah, we have a bunch of cool projects. What are the coolest stuff I might remember? Since I'm a big fan of big machinery and extricators, we have a customer who does control software for big extricators, and I think this is the coolest one, but there are many others you might imagine.
Cool. All right. Great show, no? Busy.
Yeah,
a lot of people coming to the embedded world.
Great. We have different customers showing up. Yeah.
Okay, cool. Thanks a lot.
Yeah, you're welcome. Have a good day.
Yeah. Welcome back. Sorry, I'm trying to queue up the next interview. I'll be filming with Seco, and I think they're working on something with Google and some other stuff. Sorry for the long breaks. Nice music. Hello. Good evening, Sir G. STM, yeah. Tomorrow will be a video at the STM. All right. Okay.
Zit er wel. Ik maak.
You know where it is? Sure, it's really busy. It's not like last year. Sorry?
Oh, okay.
You have the arm. Right. And the foundries. Be back tomorrow with these guys. Okay. It's a big show. Takes a while to get from one hall to the next. Hi, India. How's your internet? How's my video? Is it smooth? Is it high quality? Does it make you feel like you're here at the show? Secco, where are you? So this year, got a more basic system with the YOLO Box Pro just hanging around my neck and trying to make it more compact, lighter. And here I can click on your chat. Smooth, high quality. Thanks for the efforts. Totally possible to do that. And if I sound weird, it's because I'm listening to myself. The headphones, slight delay, so it makes me stop up every microsecond. And all right, so I'll put you in a break for a second. I need to queue up the next video.
Hello to everybody. I'm Maurizio Caporali. I'm Chief Product Officer of Secco Group. We are here with Cristina of Google, and we are here to present the collaboration with Google Cloud and Secco with the CLIA platform, with the integration of the CLIA stack inside the Google Cloud to manage the data ingestion from the edge device to the cloud, and to arrive on top with all the Google services that we have the possibility to analyze data, to have all the information.
Is ClearStack a lot of software?
Yes, we have all the tools for developers, to starting from the edge part, from smart sensors, gateway and device, to integrate, to manage, thanks to the interface of CLIA, to manage all the data from sensor and to transport the data via MQTT directly on the Google Cloud, where the open source part of CLIA that is based on a start and a jog can manage, the device manager can manage the data orchestration and create pipeline data flow directly on the service of Google. What kind of service is interesting on the embedded field?
Exactly. So our main focus is on data analytics, where we have our products that we can offer there, and with data analysis, dashboarding, and Vertex AI, which is our end-to-end machine learning platform, where we can build easily machine learning, also protocols like and applications for predictive maintenance, for anomaly detection, and everything. So we are very happy to work together so that we can build this edge-to-cloud platform, and we can combine our expertise from the hardware, from the edge to the cloud, data analytics, machine learning, and bring this on the embedded world.
You're enabling kind of like the next level of embedded ecosystem, right? When you start to be smart about what you do, it's not just a bunch of devices that are not very smart.
Yes, absolutely. Also for the AI part, the other important aspect is the possibility to manage remotely the AI model and to transfer the model directly on the device. Another important aspect is the possibility for us to help customers to define the right edge device, the right solution in the sense of chip that can integrate also the possibility to manage the inference on the edge respect to the cloud, and then distribute the data analysis from the edge to the cloud. This is very important for us.
How difficult is it for a company or somebody who wants to deploy something into this ecosystem? There's all kinds of ways for them to...
I think that's exactly why we are working together, to make it easy, to make it out of the box, to have a platform from the edge to the cloud that is tightly integrated, so all the products can work together, and we can very easily start from the proof of concept and scale into production.
For give you an example, the developer can start with Python SDK to create all the interface and to manage all the data from the machine, the complete machine with different sensors, for example, in one day, and have all the data on the cloud, on the Google Cloud, thanks to the CLIA platform.
And here at the Embedded World at your booth, you're showing a lot of hardware that support this?
Absolutely.
Yeah?
Let's go to see
Let's
some
check it out.
interesting customers.
Okay, thanks a lot. I follow you.
Okay, for first, I can introduce the main solution for this year.
Okay, let's walk right here. So what do you show here?
Okay, we are gold partner for NXP, and we have the last solution is the Series 9 of EMX6, is the MX693 with the inside we have a quad-core ARM processor plus the machine learning accelerator. As I mentioned, the importance to have the possibility to manage on top of this device the inference and the AI algorithms directly. On the other end, we have the collaboration.
This MediaTek has built-in baseband, broadband?
Yeah, this is based on 600 solution of MediaTek. Is very flexible, very efficient from power point of view. This is the base, our solution is the base for HMI solution. Starting from this smart model, we are going to present a set of HMI that arrive to 27 4K HMI solution. Callisto is the last COM-Express solution based on 13th generation Intel Core. Then I will show you directly
everything.
I will show you directly on the wall all the products.
All right.
Let's start with the module, the computer module that are our core products. We are a partner of different consortium for standardization. We start from Q7 solution to go to Smart, COM-Express, COM-HPC. We have a complete set of solutions that spread in starting from a low consumption solution, very flexible, Q7 module, full Q7, and the Nano Q7 with NXP Intel solution. As you can see, also one of the last series of MXP Mini Nano, the MX68M, the MX68.
There's all different kinds of form factors here.
Yeah, because Q7 standard can permit to have a solution that is the full solution and the Q7 Mini that is this one. On the other hand, smart module, we have different kind of solution. We have a last generation of low consumption Atom series of processor that is in this case Alder Lake N. We have the MX69 I have shown before in the wall. This is a solution very interesting also for industrial application. Alder Lake, very flexible on processor side. We start with different kind of processor with industrial solution with also the compatibility and the possibility to enable the certification of functional safety. This is very important for industrial application. This solution, this mark, is ready for the certification of functional safety of the industrial machine. That help a lot the OEMs on this way. And very flexible on the choice of different kind of process. Levy EMX8 Plus. This is interesting because also in this case you have the possibility to use NPU that is integrated on this processor. Is 2.4 teraflops NPU. Very interesting from this point of view. And then all the series 8 of NXP. We have also some products that are very small in form factor. Modular solution is internal standard, Mayon and tripads, very flexible for a small form factor battery application and solution. ComExpress, as you can see, starting from this solution Callisto, Raptor Lake P of Intel, 13th generation Intel Core, very powerful, very flexible, industrial grade, very impressive solution on this way.
What kind of customers use the Intel compared to choosing NXP?
One of the main differences for NXP, you have the low consumption solution, very small also in form factor. You have the MX8M Mini and Nano, very simple on GPU, on power consumption. For Intel, you are one step up regarding the power of the solution. We start from medium to arrive on top solution like Xeon, like Core. This is the main difference. It depends on what kind of application. For low power, low consumption solution, XNXP is the right solution. Then when you want to scale up with power intensive application, you go in the Intel solution.
Are they all fully stable, fully supported?
Absolutely.
Or there's some parts that are much more mass market and have different kind of support than other parts?
More in general, all this solution is very supported for industrial application. Starting from the NXP, we have a solid BSP, all NXP and Intel are all based on Yocto OS. And we have defined also on top of the standard Yocto OS our solution that is based, that the name internally is Jog OS, that give also a set of tools for developers to implement the IoT and industrial IoT application as I have explained before. Then a set of tools that give you the opportunity to manage the OTA updates in a secure way your OS and your system, also in the kernel side, driver, etc. And on top of this, also the possibility to update application, containerized application inside the OS. Then full support on this way, also full support for Intel on the BIOS side. The possibility to configure a dedicated BIOS for a customer is possible.
Nice. And where are your guys working on this? Are they in Italy or around the world? You have software teams?
We have nine R&D teams all around the world. The core team are located for R&D in Italy. We have two teams. One is more dedicated for embedded electronics, and another one is based for the software application. On the other hand, we have two strong R&D team in Germany, one in Hamburg and one in Wuppertal.
Nice.
And going ahead for a more complete solution, single board computer. In this case, Rockchip is another chip vendor. For,
so which one is the Rockchip?
The Sailor is RK3568.
There's many things happening on the board here, and this is also a Rockchip?
This is a Rockchip. The PX30 is an interesting solution, very flexible also on power consumption with good power performance. This is more powerful, and this is
the most
the last one.
You have
is
a
the
big
more
What do you call this?
And this is an upgrade, very, very important and very interesting. This is the Accelera modular AI chip that can give to this device more than 100 TOPS for AI inference. That can permit something very interesting from
That's a lot compared to the other stuff?
Yeah, impressive.
Big bump, big jump.
Is to give you an idea, we can manage 16 video flow directly, for example, with YOLO 4. This device with this accelerator integrate can give you the opportunity to manage 8 to 60, two from 16 video flow in real time with YOLO. It's very impressive. It's completely a change of view for this kind of device.
The NPU is accessed in the software very efficiently right now. There's a lot of things you can do with it, or is it the beginning?
It's the beginning. We are working together with Accelera, our partner, to define the right SDK with all the functionality and all the simplicity to deploy in a fast way all the solution and give to the developer a simple way to manage this. And we are in a good situation. We will release soon the solution.
And all this, what does it mean? Accelera.
Accelera is the company, the base that produce the chip is a European company. This is another important aspect. They produce entirely in Europe the chip.
They produce the Rockchip?
The chip AI chip. This is dedicated to AI. Is a AI chip
on the SoC.
And on the SoC.
So they design it.
They design and they produce. No. There are. This is Accelera. Is only Accelera.
All right.
In this case, is a kit. Is an AI kit that is based in this case on Rockchip. Here we can see the Phoenix solution that is our off-the-shelf solution. That in this case is the kit Phoenix AI Vision Gateway, because have integrated the Accelera chip as M2 modules inside. As the same way of the single board Rockchip. In this case you have 11th generation Intel Core E. You can choose from starting from Celeron to arrive to i7.
All right.
Then it's very flexible. This form factor of M2, because it's possible to integrate where the customer need more power, very more power of elaborating.
So something that goes on top.
Yeah. You can see is standard M2 connector.
Right.
Just plug and compile with the SDK of Accelera the model, the AI model, for example, YOLO, and you have the solution ready that perform in an incredible way, also for the consumption point of view, because we arrive from 6 to 10 watts for consumption.
That's why we see it on top of the chip here. Yeah. This extra board that connects and adds to the board.
Then the customer can choose. I need some application, I need more powerful, I need to manage 8 cameras, 16 per camera. I just put this accelerator on top using the standard connector, and I have all the performance that I need. Nice. CPU, GPU of the main processor is free. It's completely free for other kind of application. All the processing of the cameras, of the AI models, we can manage not only one models, 2, 3 models, 5 models with this chip. It's also an
the Rockchip is also very capable of doing a bunch of AI and also
if you need more,
and you do all at the same time.
Yeah, if you need more, you add this and you are okay.
Is the Accelera ARM-based, or is it a DSP that accelerates something specific?
I don't know the specific aspect of Accelera, but it is a specific chip dedicated to manage the inference. It's not ARM-based, it's dedicated on this for this kind of application.
Compatible with ARM, x86, anything?
Absolutely.
All right.
The last part of the product, we are very strong on system HMI solution, complete HMI for different kind of application. We have a different kind of solution, size, and based on, in this case, on NXP EMX8 8M Mini family. You can see the two versions. For the FlexiVision, you have the flexibility to use also x86 and also ARM based on Rockchip. This is the 3399 for this kind of solution. Then you can use Android, Windows, Linux.
You work with a company to make the perfect display, touch, and everything, or do you make it?
We make.
You make everything.
We have also a company that for the touch display and the LCD, and we have a production line in Arezzo dedicated on system integration. Then all the integration and all the system are in Europe, are produced in Europe.
Wow. No made in China?
No.
All in Europe?
Yeah.
In Italy? Maybe.
In Italy and Germany, we have the main production line is in Italy and Germany. In Germany, we have two production lines. In Italy, we have other two production lines. One is based on electronics solution, and the other one on system integration of the part of the system.
A lot of other stuff is showing here, the booth, huh?
In the booth, this year we have defined four main vertical market for industrial solution. We operate on healthcare. We produce many solutions dedicated to this market, also with solution certificate for this market. On top of our solution, we use CLIA for our customer to create application, to create final application, vertical application that is developed on top of CLIA.
So what is this CLIA? Is that what you talk about?
Is what I talk about. Also is the part of the Google collaboration, is solution for developer that give the opportunity, the possibility to implement in a fast way IoT application. We give SDK to connect the device, to transfer the data from the edge to the cloud in a simple way, and we give all the tools also to develop application on top, front-end application directly using CLIA, that is the core platform, the base platform to manage this. Then the customer is very fast to develop a specific application, specific vertical, and we offer all tools. CLIA is hardware agnostic. Then it's not important to have our hardware. You have all the SDK for different kind of solution, ARM, x86, Linux, Android, ASP32. The developer directly use this SDK to connect the device to send the data to the cloud. Then it's very flexible in this way, and also is cloud agnostic. You can use the cloud of our partner Google or our partner Microsoft Azure. It's not a problem. The CLIA packages is also possible to have platform as a service, is containerized, can be deployed immediately on the cloud of the customer. Also in directly on the server of the customer if they want on-premise solution, for example.
What are you showing right here?
Here is an application of an example of application of our customers that in this case is testing solution for security reason for hospital where there are a patient that are lie down on the bed and need to be alert when try to get up. And in this case we use on the edge device an application that is an AI application based on computer vision that is deployed using CLIA that manage the alert and send the data to the front end. Here the customer had developed a front end application related on the specific need, where have the information about the room, the status, the room information, and the alert directly on the mobile devices.
Is this one of the latest?
This is one solution. Is not the latest, but is one of the main solutions that we have that is based on Intel chip Atom. The Atom have very good potentiality, as you can see there, from point of view of video analysis. We arrive at 13 FPS with no problem for this kind of application. This AI model is performed on GPU, on the Intel GPU that is optimized through OpenVINO. We use OpenVINO to deploy this application, to optimize this application on the device.
Nice. There's many cool demos at the show, at the booth here, right?
Let's go to the industrial solution. Very interesting solution. Here, SIW is
let me take a look at this. Yep.
Our customers. In this case, this solution is based on the solution you have seen, the Alley is the smart solution based on functional safety. This solution is dedicated to functional safety in the sense that we have the possibility to analyze the status of the device and to see if all it's okay. Automatically the system can detect the person that are in front of the system and can perform a stop of the solution. I will show you. Now is enabled the functional safety solution. Okay. Well, when you have set is very similar aspect is based also in the Alley solution. That is a radar from Inspect. They produce this kind of radar at the same time for security reason of industrial machinery that move in a physical space. They can detect critical aspect immediately, and this is thanks to the functional safety enabled certification. The Inspect have the possibility to develop a solution immediately ready for this market. This is all the data that are coming from this industrial machine can be managed directly with CLIA. In this case, CLIA is installed directly on the plant on this server. This is, in this case, a gateway, our gateway. All the server CLIA platform is here. All the raw data is sent directly here and can be managed from a point of view of quality of the production. We have the possibility to analyze directly the quality of production, daily consumption per place, and we can also manage energy status, energy efficiency with the CLIA platform that manage the different kind of products.
What's running here?
Here is a product of Camozzi. This is based on our HMI, FlexiVision. This is the real-time solution. In this case, this arm manages the weight, measuring the weight when he takes the pieces, and can manage also force control. We'll take this part and can manage this force control. All the data are visualized by the application of Camozzi. The application is managed from low-level point of view by CLIA to update the application, to see the status of the HMI, and all the data, the analyzed data, are sent to the CLIA servers for the integration IoT solution integrator.
So SECO is in energy, all these is huge industries, right?
We work in many.
Potentially.
We work in many industries. Obviously, we produce solutions that are very flexible on this way. We are very strong to define the right solution for our customer that could be in different market, and we help the customers to find the right solution in sense of potentiality, electronics power, electronic flexibility, and software, embedded software, and all the solution to arrive to transport the data to the edge, to the cloud.
And here you have a whole meeting area with all your potential customers talking
the other
here,
part,
and
yes.
the demos here.
Because
it's a busy show.
It's a busy show. It's a show more related on this aspect, to have the possibility to meet here all the partners, all the customers, to meet new customers, to have a meeting to discuss about technology, to discuss about the possibility of the market, innovation, etc.
All right, cool. Was there more you wanted to show? The coffee machines?
I will show you only the last demo. This is a kit dedicated on fast charger solution. We have a solution modular that is based on smart devices with carrier board, with the possibility to configure different kind of LCD. This is 32 inches LCD plus a touch display 10 inch. Plus our payment system. Here is only a demo, a complete demo to show the possibility of this solution. This demo is done together with Imagen. They produce the inverter. It's very cutting-edge technology of inverter. It's based on Intel FPGA to optimize the production of energy, the transforming of the energy. In this case, Imagen arrived actually at 200 kilowatt for the inverter with a very, very small dimension. This is very impressive. If you can see other inverter that arrive at 100, 150 are very big and large because they need dissipation. Here, the energy production is very optimized thanks to this solution, and we don't need too much dissipation for this.
Oh, that's awesome. All right. So thanks a lot for showing
You're
everything here, the Embedded World 2023, and people can just contact you.
Absolutely.
The future.
Thank you. Thank you so much.
Cool. All right. That's perfect. I'll just put people on the break. All right. It's just a question about your light. Okay, let's do it like this. Okay. Hi.
Hi.
Please introduce yourself.
So I'm Bowen Zhang, and I'm working for the Sunchip company. And now we're at the Nuremberg Messe, so the exhibition.
And what do you show here is a bunch of Rockchip products?
Yeah, these products are developed and manufactured from our company, but the chips are based on Rockchip. So it also, one of the greatest advantage of those mainboards is that they can support Android system as well as the Linux system.
What Linux? Which Linux you support?
This is the Linux system.
Debian,
operating system.
Yocto project, some different kind of Linux. And what is a Rockchip? You have RK3588, for example. Which one is?
The newest one, but it's not here.
It's not here.
It's not here. Yes.
It's coming soon.
It's already embedded in this box.
So it's here.
Yeah, so it's here.
So what is this?
So as you can see, this is edge computing box, and it's also based on the RK3588. Has multiple interfaces. So you can support different applications in smart city, commercial use, and like robots, industrial robots as well, and for the multimedia player and yes, etc.
It's got many ports, many
Yes.
connectors. What am I looking here? Speaker outputs.
Yes, and to Wi-Fi. Yes, Wi-Fi, min Wi-Fi and min Wi-Fi sub.
All
And
right,
we can
I can
also
even
add
hear
some.
the interference in my microphone.
Yes, and we can also, according to your needs, add different functions. So customization is always available by the SunChip company.
Nice. What's the price?
The price is secret. I can see now. I can now see it publicly.
Depends how many.
Yeah.
People contact you.
Yeah. You can contact our sales manager Julie. So she will tell you the details about the prices.
Is this the display?
Yeah.
With
that's the
touch?
person. Yeah, of course.
You make this?
Yes, of course.
Is that your office
This
in
is
Shenzhen?
Yeah, this is Shenzhen, and this is a video of our company.
All right. What are these boards?
This board's different.
It's got the 3399 or
Yes.
3288, 3328.
Yes,
All
already.
this.
All this, yes.
All right.
They're also based on the Rockchip.
It's good embedded world for you? Very busy?
I think it's pretty good. Yeah, the people here are really friendly, and the booths here are very colorful, and different companies from different areas also join this adventure, and I really enjoy this.
Cool. Thanks a lot.
Yeah, thank you very much.
So you have my card? Let me give you. Yeah, this one. So the video go here.
Okay.
If you want, send me the little email with the product name for this description, what I should write on the YouTube.
Okay.
You can send it to me and then I'll publish. And let your colleagues know in Shenzhen that maybe they should invite me. I do video at their office.
Okay.
So they can send me email.
Cool.
And I will send you the video. It's already live. It was live, but tonight it will be in 4K.
Okay. I standard. You can provide 8K. You should buy it.
Where do you live?
I live in Germany.
In where?
Erlangen.
Is that near which one?
So this city is Nuremberg. So it only takes 20 minutes from the Nuremberg train
you're
station.
right next to here.
Yeah.
Oh,
You can see that.
student.
Yeah, I'm student here.
What do you study?
Electrotechnic. So electrical engineering and information technology.
Cool.
Yeah.
All right.
Is this still alive?
Yeah.
Oh, still alive.
Yeah, but I'm filming the wall.
Okay. Cool.
Cool. Okay. Thanks very much.
Thank you very much.
See you. Bye-bye.
See you. Bye-bye.
See you. Bye. All right.
Please.
All right. Let's walk around here. Okay, guys. I think I'll put you on a break for a second. Here we have some Ampere. Can I do a video? Let me take this. All right, so now we're live also. Hi, please introduce yourself.
Hi, I'm Joe Speed with Ampere Computing.
And this is your chip right here. This is doing a lot of noise in the industry right now. Huh? What are you looking at?
It is. It's a 128 core CPU with 128 PCIe lanes. And these are used in everything from Google Cloud to vehicles and 5G base stations.
And so it's a big chip, it's a lot of cores, and it's also a lot of performance.
Yeah, it's a lot of performance, but it's a lot of efficiency. So this is 3 times the performance per watt of x86, like legacy architectures.
3 times?
Mm-hmm.
That's a lot.
Quite a bit, yes.
That's like a big shift. And here in the embedded world, the argument is that you want to bring this to the edge That means
Yes.
potentially billions or millions of devices.
We would settle for millions. Millions would be okay.
That's millions of base stations, 5G?
Yeah, so 5G base stations, smart city, industrial automation, mill aero, and all kinds of other applications.
What are we looking at here? Maybe you can explain. What is this?
So this is an industrial PC. So this is a fanless, ruggedized industrial PC with the Ampere processor and with optional NVIDIA GPU, so you can have a Ampere CPU with your NVIDIA Ampere GPU.
This is a full contained, self-contained, the whole thing is
Yep. And then this is a AI computer for autonomous race cars.
Autonomous race cars.
Yes.
So soon Formula One will be robots.
We'll see. But it's not really. It's people ask sometimes, like, is it about humans competing against machines? It's actually. I've been a long time involved with a program called the India Autonomous Challenge, and these aren't in the vehicles yet. We want to work with our friends D-Space to put Ampere into theirs, and they so it's a university software contest.
When you put a 128 core in a car, you get a lot of potential self-driving happening in there?
Well, it's really a software problem, but we help. We do our part.
Because is that also the market for this one? Go in the cars?
So probably not all the cars, but I think it's very good for R&D fleets, for specialty vehicles, autonomous people movers, earth moving, mining, agriculture, things like that.
Can you hold this board?
Oh, sure.
And try to explain what are we seeing on this board?
So this launched here today. So this is a dev kit. This is the Ampere Ultra dev kit. It's made by our friends at AD-Link, and you can visit them over in Hall 3. And it comes with the memory, the heatsink, storage, really all the things you need to do to, like if you're making devices, okay, and things, and you need to develop device drivers and test them, or you need to see how easily your software can port to this architecture, this is the kind of thing that you would use.
What do you connect here?
So this is 3 PCIe by 16, so you could, for example, put like 2 full-length, full-height NVIDIA GPUs plus a camera frame grabber.
3 GPUs. And
Well,
you
could.
address all of that.
Yeah.
Plus 2 what?
This is 2 PCIe by, I think, 4 or 8. I don't know, I have to check. So you could put like NICs, network cards, and other things.
And what's connect up here?
Oh, so we have more Gigi, USB, VGA, serial, just normal things. Nothing exotic. Yeah, we kind of work hard to make the ARM as boring and painless as x86 is in the data center.
It's been a decade-long work
Yes.
in progress to optimize the ARM for servers. And now, would you say it's 100% fully smooth and actually even smoother than other architectures?
I don't know if it's smoother, but it's widely deployed. You look at the Oracle Cloud, Azure Cloud, Google Cloud, people like Hetzner, Equinix. You look at products from people like HPE and Supermicro. It's very much mainstream now. You know, people really want the density, they want the cost savings, they want the energy savings, they want to figure out how do they make their compute footprint green and sustainable and reduce the carbon impact. And so we help with all of those things. And now we're bringing those same benefits to the edge.
If I go on Google Cloud or Azure, I can click and I can get an Ampere instance.
Oh, sure.
And it's great to work with. And it's good price compared to some of the other
and
architectures.
the Oracle Cloud, they've been doing impressive things. They're running like large-scale, heavy AI workloads on Ampere, on the Oracle Cloud. So that's pretty interesting as well.
And here you are, I was seeing right here, there was some right here. These are the different booths where you are. AdLink, AWS also, automotive, Lattice.
Yes, the AWS Automotive, if you look at the Yocto project, so the Yocto project is using Ampere for all the things they're demonstrating there in the booth, working with AWS Cloud and with the other Yocto project members.
When I hear about Yocto, I think about small stuff, right? But it goes all the way to 128 core?
Yeah, Yocto has grown up.
So it's happy to work all the way up?
Yes, very much.
What's the challenge when you make software and you want to use so many cores? You need to be very good at parallel processing in your software?
Actually, in the open source community, a lot of people are taking care of that for you. So you've got so many workloads that are being developed for the cloud, and by their nature, they tend to scale out across many cores. And so any of that software that's designed to scale out across many servers is very happy running in one SoC using all 128 cores.
One thing that I guess is a challenge, but it's hard to talk about, is the price of a chip. But that's not the main question, right? Is the price of the power to run the chip. That's the main difference,
so there's
right?
a few things. So there's you can look at things like performance per dollar, you can look at total cost of ownership. For the data centers, the exercise is how can I get more compute per rack while using less power, okay? And then you save so much. Well, now we're bringing those same kinds of benefits to the edge, where if I can get more compute into a device and use less power, that's very good, right?
Before you said 3x.
Yeah.
And that was power
performance per watt.
Performance per watt.
Yep. But also if you look at things
in dollars?
Yeah. When you look at the TCO, sure. And that was also looking at things like, how much compute per rack or how much compute per device, okay, that I can get in the same power budget. So there's two ways to think of it. I can get triple the compute for the same power budget, or for the same compute, I can get using only 1/3 the same power. And so that's a really big savings, and that lets you make very powerful devices that really don't use that much electricity. So that's a great benefit. So we see, for like 5G base stations, there's like 30 companies working around 5G base stations, software accelerators, the whole stack integrated, and they're using our processor in that.
I like watching these weird videos on YouTube with people customizing vans, and they have huge Tesla Powerwalls in their van, and they have a whole bunch of power. Maybe they could be driving around with the little base stations. And when there's an event, they go and add 5G capacity at the same time as, they sleep in a van or something. Maybe this is this kind of stuff maybe that could go in a van.
Yeah, definitely so. There's people making some small, powerful things with us, and the benchmarks I've seen around like 5G base stations is moving from x86 to Ampere. For the same power, they're getting double the throughput.
Could you use a Starlink and make a 5G base station out of the Starlink connection, I guess, maybe? And then suddenly, it's just, I don't know, it's a weird question. Okay, and here with the 7 Starlink, right? It's partnership and doing, what kind of work are they doing with you?
Yeah, so they work with our other partners, people like AD-Link and Gigabyte and Supermicro around taking these compute modules and motherboards with the Ampere processor and making these rugged, extreme rugged, frankly, compute for different kinds of applications. So, think like buses, trains, ships, subs, all kinds of things.
Wow. What happens when you put this on a bus?
You're able to do more using less power. So if you want to do like a safety or traffic safety with cameras, you can do all kinds of interesting things.
There could be cameras inside the bus, make sure everybody's, I don't know, I'm not going to say distancing, but they're all comfortable. Everybody's getting what they want. And they get a VIP service on the bus, maybe. Or are these kind of like development boxes, or?
No, this is for development. These are very much for production deployments.
So they're actually made by 7 Starlink.
Starlink.
Yep. 7 Starlink. What's the difference between this and this? I see more cooling, so it's because
so
it's a GPU?
What this has is, you see the two fans, this is sealed, but the two fans blow air across the fins, so it has more cooling, so you can put a more powerful processor and a more powerful GPU.
All right. Cool. All right. So you were at the Mobile World Congress. It was a big story, right? To run the base stations.
Mm-hmm.
You're all about doing that, and there's a big demand for that.
Yes.
And here, the embedded world, is this different kind of demand?
Yeah. It's a different domain, a different application, but some similar challenges. So what's happening is you're getting more and more sensors, and the sensors are becoming higher and higher bandwidth, and the communications is becoming higher bandwidth. And so the challenge, but you don't always have, you might be constrained, you might have a fixed amount of physical size, weight, and power, so the swap available for your application. So it becomes this issue of how do I get more compute into my existing size, weight, and power.
All right, so it's very relevant for everybody here who look for being at the extreme edge.
Yes.
Like the high performance edge.
Exactly. Yeah, and we don't do, everyone talks about the 128 core, but we also go down to, 32 core, right, with below 40 watt. So, we can actually cover a pretty wide range of compute requirements and power budgets, but even at 32 core, we're giving you 128 PCIe lanes. So all of your I/O. So if you need to do like portable NAS or any other kind of application that's really demanding, or CDNs, that's a popular application for these. We have some much lower power, highly efficient parts that you can use for that as well.
And I guess there's a lot of partnerships in the software world, not just Yocto?
Yeah. So we do a ton with like Canonical, with Red Hat, with a lot of ISVs. We give heavily to the open source community. So we have hundreds of engineers who contribute to open source full time. So we have open source BMC, open source firmware, so the Tiana Core, EDK2, OpenBMC, all these kinds of things. And a lot of upstream contributions to things like GCC and LLVM.
So all the work that the guys at Linaro and elsewhere have been working on for decades, you're able to take all this and improve and give back to everybody.
Well, I wouldn't even say we take it, we just contribute upstream. We're just trying to help the community and help everything, so you get this painless out-of-the-box experience, okay, and everything just works.
All right, but even though it just works, it's still a challenge to learn how to use so much parallel processing, or is that just something that everybody that works in the cloud knows how to do?
Yeah, and it's not necessarily just about like, how do I get one process, one workload that use 128 core? You have a lot of mixed. So think about if you do a robot, okay? You've got perception pipeline, path planning, control. You have all of these different workloads, and being able to run them all on the same SoC, which in the past, maybe you would need many separate computers. So if you have an application that today is requiring many separate computers, you can collapse that into one chip.
And I guess your colleagues are very busy on the next gen and getting smaller nanometers and everything.
There's a new product that will be announced at some point, but it's not a matter of like, this is V1 and that's V2. That actually has some, interesting characteristics. And so this is, for the edge, for these kinds of things, this is very compelling.
Nice. That's awesome. And eventually maybe even the governments will get involved and start saying, hey, cloud is a certain part of our energy consumption in the country, in the cities, and they will start saying, I'm not going to say they're going to mandate our servers, but they're going to tell everybody to be conscious and use less power.
Yeah, so I certainly won't pretend to speak for government policy or any of those things. I will say that we help companies do more with the existing data centers and minimize their impact on the local communities.
Cool. All right. Thanks a lot.
Hey,
Thanks.
Real pleasure. Thank you.
All right.
But his style is more like You start there, but then you walk around.
Okay, okay.
Yeah, I'll check out the Micro E just later, maybe tomorrow. What did you say?
Should he look at the lens or look at your face?
Ah, both is okay.
Wonderful. Okay. Okay.
Hi. Please introduce yourself.
Okay, yeah, okay. My name is Martin Ting. I'm the founder of 7-Star Lake. And the 7-Star Lake is company focused on the rocket mission, the computers. So we design and manufacture all the ruggedized of the computer based on the military application and autonomous vehicle. Basically, once the customer need a heavy duty, high combustion power, or the high performance, they come with us. Yeah.
And what are we looking at here? What is this stuff?
Okay, and for the embedded world 2023, as we know, is very important. The largest embedded trade show in the world, and we demonstrate how we make those PCI wonderful ruggedized military the motherboard. Like it means those motherboard they can sustain more than the 100 G about the shock and also the vibrations. And those products are very good for autonomous driving and also for kind of different kind of heavy duty vehicles.
When you say military, it's military spec, right? So
yes.
that means drop
it's
water.
like for military, it means the product what we design, so we can certify from the temperature range minus 40 degrees but up to 70 degrees without any fan, and even they can do IP65 for waterproof. As you can see, many different kind of the military vehicles or the ships, they are in a very harsh environment. So basically, we can all design those products. So for example, you see like this one is a 19-inch half. The rack mount chassis is highly the CPU, GPU stuff, and then they can easily put it in the transit rack mount. So in a battlefield and any ground vehicle, they easily carry this one. And also everything is based on the combustion core. So you will see it's no any moving parts inside the system, and they can ensure the complete system can survive in the highly vibration and shock, and even
so you say middle standard thermal shock vibration?
Yes, certified, and also including the EMI and EMC certified. So these two are the key about the whole 7-Star Lake's product range.
What's this NVIDIA Quadro, Intel Tiger Lake?
Yeah, okay, good,
That's what you
good.
have.
Okay, the Intel is the global leading semiconductor leaders, and the Intel can support a very, very high quality, high performance CPU. So we are using based on the Intel Tiger Lake H, can up to about 8 physical cores and 60 threads. And NVIDIA GPU is one of the best artificial intelligence about the processors. They can deal with a lot of huge image and also keep the good performance. So in the ground vehicles, as you know, is a need to deal with a lot of the sensors visions and the fusion. So they need so these GPU, CPU servers is perfect to deal in the battlefield.
We see a truck here.
Yeah.
What the truck is going to do with this?
Okay, as you know, autonomous driving will be the future to help the human beings to have more the safety, the mobilities. As you know, from the level 3 to level 4, level 5, the challenging is like about they need always have a high performance computing nodes. As a 7-Star Lake, it's very good to design with multiple CPU, GPUs. So it is not the trunk could be the first the vehicle and highly adapt autonomous technology. So that's why we provide the 7-Star Lake GPU, CPU servers, and with the dual Xeon scalable processor and with NVIDIA GPUs in all different kind of level 5 autonomous driving the truck.
Nice. Is it already working or is it just a work in progress?
No, we already, actually the 7-Star Lake start to provide the GPU computers from the global leading autonomous vehicle companies, including the US, the Google, and the GM, and the Volvo, and also in a majority of the European vehicle makers.
Right.
So it's already done in using the 7-Star Lake GPU computer in the vehicle since 2014 until 2022. And then also I would like to introduce about this is our partner, the Ampere. As you know, the Intel processor is good. They get up to 16 core, 40 core. But for Ampere is based on the ARM architecture.
There's a very, very low power consumption, but with a huge the computing cores. And so we partnered with Ampere to launch about 3 types about the top edge AI computers. One for kind of about the railway rolling stock, and another one for the autonomous driving, and another one is for heavy duty the military, the vehicles.
So how do you design these? Are they very special integration?
Yes.
Like nobody else do it?
Yes,
like
okay.
this?
For example, the Ampere is one of the most important data center, the semiconductor provider. So Semistar partner with Ampere to use his processor, but we ruggedize with the complete system to meet the rolling stock standard EM5155. As we know, nowadays, all the rolling stock, they need to deal with the hundreds about the cameras. And with those hundreds of cameras, how you can recording over the image and those videos, and in anti-vibration and shock system. So Semistar customized with Ampere, the 64 up to 128 core processors in a ruggedized server.
Nice. Is this mass production or just prototype?
It's a mass production. It's already mass production. And besides of those kind of the high core count, with the Ampere's processor, we can support up to the older flash, like up to the 80 terabyte with one computer. So it means you see these top 3 edge computer, they are not only supporting the high computing power, they also can support the very, very large capacity of the storage. So it means the
inside
user.
There.
Yeah, inside. So we can have inside.
Full hard disk.
Yeah, the whole flash.
Or SSD. Flash.
Yeah, the NVMe. So we support very high-speed NVMe, support read and write. So for example, they can deal with the hundreds about the cameras and the recording, put all the data, and for a rolling stock, the operator, 1 week, no need to swap all of the SSD.
So where is it going to go? Is it going to go in the van, car, special car, bus?
And so except to the rolling stock, those computers also can be doing CDs artificial intelligence, the labeling and the object tracking with the Ampere's processor and with the pre-built-in the algorithm. For the object detection, they can do a very, very, very high efficiency, and they can detect all of the objects and to help the smart city to provide a more safer environment.
Stable environment.
Yeah, stable. And for example, as we know in the coming future, all the vehicle will be electrical bus, and the electrical bus they will integrate with the cameras. So for those the high performance the edge AI computer, the built-in with MP processor with AI algorithm, they can easily help the transportation operator to do a kind of about the heat map and to understand where have the traffic jam and how they can improve the public safety. We also have the monitoring about the pedestrian behavior, something like that, extra.
And it's not going to use all the battery on the bus. It's power efficient.
It's power efficient. For example, for this Ampere's 80 core, 64 core, it's very, very low power compared to other semiconductor manufacturer. It's only about 30% about the power consumption. So it means it's a very longevity and sustainable for the whole environment.
And when you, on the wall there, you show trucks.
Yes.
And buses.
Yes.
And vans, and they all connect. And what do they do?
Okay, what's the mean? Okay, like with MPS infrastructure, we know no matter which kind of the vehicles, if they can integrate with the MPS, the top edge AI computer, and then we talk about we can collect all the data, okay, from the smart cities, and we digest the data, do the labeling, object tracking, and we transmit the data to the cloud. So it means we can help a city government to build a digital infrastructure. So it means that all kind of the vehicle is a mobile sensors. So they can collect the data, digest the data, and transfer data to the backend systems. It means from the edge to the cloud, it's a completely, the infrastructure can help a city to build a safer transportation and a better world for human beings.
Are you talking to some cities, talking some countries?
Yes, you know, the 7 Starlink, the smart city solutions has been deployed in the city, in the Taipei and in Kaohsiung, and for those cities can help the transportation development to decrease about the car accident in the intersections. With those solutions, like we can provide real-time dynamic data. The data were including the traffic jam and also the traffic.
When I think of the future, people talk about self-driving cars will be so much safer. But before we have every car be self-driving, maybe you'll have the buses help all these cars that are not self-driving be more safe.
Yes. Okay. That's very good. That's very good. The agenda. As you know, the autonomous driving maybe cannot be 100% be adapted in the coming 5 years. However, if we can adapt this autonomous driving technology, for example, level 3, if we can use those level 3 technology and with Ampere's processor and with 7 Starlink algorithm, I believe those bus they can do a lot of very good smart traffic management. So with those smart traffic management the solutions, we can help the city to monitor all of the traffic transportation status, and we can predict where is the construction, the area, and how we can improve the traffic situation based on the real-time data capture.
And keep everybody safe,
yes,
hopefully.
We'll keep everybody safe and lower the car accidents.
Nice. And over there,
yes.
What do you show? Is this your products?
Besides a lot, we're talking about a lot of the heavy duty, the panel computer, and this is the 3UVPX, and this is the airborne computer, and this is in the ground vehicle, and you see the ruggedized computer. Like we do a lot of with the military customers. As you know, the military, the vehicle, they need a very ruggedized and they're high reliable. So with the 7 Starlink, the Intel, the base about the solution, and everything is fully certified by military, the standard A10, and also EMI, EMC 461, the fully certified.
Cool. So it's a good embedded world for you?
Yes, embedded 2020 embedded world is the most important and the most successful. The computer the show in the market, and the 7 Starlink is participated in this show, and with our partner, and we believe it's a very important show for all people.
Are you also in a Computex?
Yes, we will be in the Computex. And are you coming to Computex?
Yeah, I hope so. For sure.
We will also have our own forum, and also we have the dinner party to launch our product. So we hope we can invite you, become our guest in Taipei.
What is the history of 7 Starlink?
Okay, 7 Starlink's company, we established in 2010, and we started to design and manufacture. The rocket. We started to design the Ruggedized, the stackable. You see, this is a very special connector, and what we can do, like the rocket stackable, and they can keep the product highly reliable and anti-vibration and shock with this very ruggedized messaging type of connector. Okay, so we start to do this kind of the CPU module, and then we are also making our own the special DC-DC power converter to sustain all the harsh environment. And then the company now, we have the two parts. The hardware, we're doing the military heavy ruggedized GPU computer and also liquid cooling server. In the software part, we do the AI smart traffic management solutions.
Is it a big team?
Yes,
everybody in Taiwan?
Yes, we are all based in Taiwan. It's around about the 40 people. So we are very focused on the hardware and the software.
Cool. All right. Thanks a lot.
Thank you very much.
Thank you.
Thank you. Okay. So. Okay.
So back with the live stream. Sorry, it's a lot of walking.
This is one thing that
compared to what you've seen last time.
I'm gonna try to film with these guys over there. Here's a Risk 5. I'm doing live shows. Okay. Let's go this way. It must be there. Okay, so I'll put you right back on break, sorry, for a second. Hi, please introduce yourself.
Hi, my name is Shai Kamin Brown. I'm Director of Product Marketing for Low Power Edge AI with haptics.
And what are you showing here?
So we're showing various applications, primarily using our DBM10L Low Power Audio Edge AI chip. So one of the key applications we're showing here is sound event detection. So I can play various sounds using this speaker over here, and you'll see various devices detecting it, all happening in extremely low power. So we're talking about between 1 and 3 or 4 milliwatts while detecting the sounds, and this is thanks to the low power capabilities of our chip, which is, as I said, a low power audio edge AI chip, which includes both a DSP and a neural network processor.
So I see the chip is right there. Is that the one in the middle there?
Yeah, this one over here is the chip, DBM10L. This is one of the packages, QFN package. There's also a CSP package, which is much smaller.
All right. So how does it work?
So first thing I want to show is glass break detection. So I'm going to play glass break on this phone, a glass break sound. It's going to go to this speaker over Bluetooth. The speaker will play out the sound. It'll be picked up by this device over here, the white device that includes our chip in it, our low power edge AI chip with a single microphone. This LED will turn on. And then the device also has a ULE long range, low power wireless technology that will send a message to this device over here, this commercial Fritz box, which will then send a ULE message over to this device that will turn on. So let's see all of this happening in real time. So I'm playing the sound on here. It's picked up by this device.
Detected glass break.
And the light turns on, all happening wirelessly. Okay. Now the next thing I want to play is baby cry. So this device will play the baby cry sound. And this device, which is connected to one of our EVBs, will pick up the sound using one microphone, running a different neural network on the same chip, and play back a confirmation that the baby crying was detected. So I'm playing it now.
Detected baby cry.
So hopefully the sound is high enough, and you could hear the device saying detected baby cry.
It's like a trigger.
Yeah,
it's a trigger word,
no,
but it's
not
a trigger
word. It's a trigger sound.
Sound.
Yeah.
It could be any baby. It's not the same
any baby
every
yes,
time.
of course. Any baby, just like any glass break, any gunshot, any. We detect toilet flush for some customers of ours. Next one is we have a really nice industrial application, which is really recently made by our partner Imagimob. And so you'll see. I'm going to play a welding sound. This is what a good weld sounds like. So it's playing out of this speaker, picked up by a microphone over here, and you can see on the screen that we're detecting this is a good weld. Now I can also play a bad welding sound, picked up by the same device. And now you're going to see that it's supposed to say bad weld. Maybe we can edit this later. Let me try again.
Yeah. So
you see now it says bad weld. Okay, it says bad weld because this weld was not good. Okay.
Is there a difference when you play the sound from the speaker or actually happening? It's a different echoes and everything.
Yeah,
and you are
real time
optimized for
is
the
actually,
real world.
all those demos, of course, have some limitations to them.
How do you program a scene? How do you program something you want to detect?
So the way these things are constructed is using multiple samples. We're talking about hundreds, sometimes multiple thousands of samples that are provided. Either we collect them or the customer collects them. And then we have ways of training, basically training an AI model. This is done offline. And then loading that model onto the chip in real time to detect these specific sounds. Now, a similar technology can be used for detecting keywords. So in this case, this is a commercial remote control from Hisense that's used with this premium TV from Hisense. And this has the same chip, DBM10L, with a couple of microphones, a keyword detection algorithm from Amazon, and the microphones run our own noise suppression algorithm and beamforming. So I can say, Alexa, go home. So this is your standard Alexa experience on a remote control. And what's special here is because of the low power capabilities of our chip, you can design devices that last, in this case, maybe something like a year on a couple of AA batteries.
Really?
In the case of these devices...
And it's listening all the time?
Yeah, it's listening all the time. In the case of these devices, this device, for instance, could last 5 years on a couple of CR123 batteries, or something like 3.5 years on 3 AA batteries. So it's a very, very long life, which allows our customers to deploy these devices to places where installation is not easy. So you don't have to draw any power lines, basically. You just lick and stick. You know, put this on a wall somewhere, stick it on the wall, it lasts 5 years. The last thing I want to show, this is biometric voice authentication. So in this case, it's the same chip, the DBM10L, running an application or a software from a partner of ours called MyVoice. And in this case, this is biometric voice authentication. So earlier I enrolled my voice in this, and it's a very simple enrollment, just saying a certain command 5 or 6 times. And then when I'm talking, you can see if you turn the camera here, you can see when I'm talking it says authenticated. You see, and that's really what says that the device is authenticating my voice. Now, if somebody else talks, it's not going to authenticate them. You can enroll multiple people, and you can use this for various security applications, parental controls, and things like that. And this, just like all the other demos, is done in sub 5 milliwatts while it's detecting, and so you can last a very long time on some batteries.
How does that work? How can you make it such low power?
So the main trick, well, first of all, we've been designing chips for many years, so we know how to design them for very low power. And we have tricks in our software for that as well. But the main thing here is the fact that we have a neural network neural network accelerator, basically an NPU, integrated into the chip. And so when you design a neural network model, software that is, to run on that processor, on that core, it can run in extremely low power. That's how we do it.
So AI, neural networking,
AI
works at 2 milli, what do you call it?
1 to 5 milliwatts. Between 1 and 5 milliwatts, yeah.
There you have, that's very low power.
That's extremely low power, correct, yes, yes. That's contrary to what you do, for instance, chips like from NVIDIA and guys like that who do very high performance. For us, the trick here and the focus is low power.
One thing I've always wanted to do with my Hey Google and everything, and is to give it my own name, to customize the trigger words.
Yeah.
Is that something that's potentially possible with these kinds of devices?
Yeah, it's not just potentially, it's totally possible. Yeah.
So I could say, hey John, if I wanted the device to do that, if the people who sell the device let me do that, and they put your chip, in theory they could let me train any trigger word I want.
Pretty much, yeah. I mean, Google and Amazon will never do that, but other companies will.
But why wouldn't they?
Well, that's a branding exercise.
They want people to say Google 1,000 times at home every
Exactly,
week.
so they remember the Google brand, but also for quality. When you train a wake word extensively, like Google and Amazon have, and like we have in this case, or Hisense did, you can get very high quality. These models where you train your own wake word, they're never as high quality, their performance is never as good as something that's trained offline with a very, very long
But the more
process.
you use it, the better it gets, so that's not how it works?
That needs to be developed.
It needs to be developed, but it might be good enough for...
Yeah, it's good enough for some applications, yeah. It always depends on what distance you want to get, what noise you have in the environment, how important the performance is. Those kinds of things need to be considered.
And what do these Hey Google kind of devices have compared to what you do? You have a dedicated chip that does the wake word stuff, or they also do, or they do differently?
So it depends. We have devices that do Hey Google detection, just like here I showed you Alexa detection. So we have those as well. What we do that's special compared to, for instance, your standard Amazon Echo Dot or Google Home is that we do this in very low power. You haven't seen much, and you've seen actually very, very few OK Google enabled and Alexa enabled devices running on battery power.
Yeah, that's amazing to have such low power. Is this the lowest power in the world for this kind of application?
It probably is, yes.
Which it's always ready, always listening.
Always
you don't
ready,
need to push a
always
button to
listening,
start it.
Yes, no push to talk. Well, this device also has push to talk option, but the point is, if you have to hold the device in order to activate it, you might as well press the buttons. But the idea is it's on the coffee table. I'm not touching it. I'm just talking it from far away. I don't have to do anything. Just sit back on my sofa and talk.
And it's good to have it closer to you. The TV is far away. It might not be as good
that always helps with performance. But we have, like I said, we have 2 microphones here, and we run our own algorithms, very, very high performance algorithms for noise suppression, and we actually use beamforming here. And so even when it's pretty far away from the user on the coffee table, and not directly close proximity to the user, and even when the TV is playing in full volume, it'll still pick up your wake word. Actually, this environment here in Embedded World is extremely noisy. So that's why I'm talking so loud. It's very hard to even hear ourselves talk, and this device can still pick up my keyword.
Nice. And maybe we can speak with your colleagues also.
Yes,
here
please
at the
go
booth.
ahead. Yep.
Yeah. All right. Thanks a lot. Hi.
Hi.
So please introduce yourself. What are you showing here?
So my name is François Béchon. I'm FAE for Synaptics, and today we are going to present the TDDI technology from Synaptics. So what we are doing is that we are selling.
Let me jump right here.
So we are selling TDDI, so touch and display driver IC, to a display manufacturer. So the purpose of this device is to drive the display, so to display the content, and also deal with the touch aspect. So we are selling one component to the display manufacturer. Here we are showing here what is currently sold in the EV car in the US, Lucid. It's showing the display technology. Here it's active part as well. If we have freeform display, so it's not only rectangular, we can deal with freeform, both on both sides here and there, and it's curved as well. So meaning the silicon that we sell can also bend. So this is part of the thing that we can deal with.
Silicon that you sell, so there's a chip and there's displays and there's the display and the touch, but everything is in one chip.
Everything is in one chip, but we sell the silicon only to the display manufacturer. They put it on the glass and it's done. We provide the solution for the display and the touch.
What is this silicon you're talking about?
This device, TDDI, touch and display driver IC.
And the chip is somewhere?
The chip is glued on the display right here somewhere, just beneath there. And then there is a glass which is glued, which is assembled over it.
Is that how every touch display is made?
Right now, yes, because it's a new technology. The advantage of this technology, which is called in-cell, is that it's cheaper. It also has better optic performances because you have less layer, so you have less reflectance from the light. So it's better.
So there's been a lot of development over the last decade in capacitive touch.
Yeah.
And is this like the best, most advanced implementation of capacitive touch?
Yes, it's capacitive touch. The most advantage of that is also it's naturally immune to humidity, to moisture, and it's really advantageous. It's a lot of
performance is very good with satisfaction of the customer. The touch is happening efficiently, precisely.
It's really precise. We have a lot of advantages within Synaptics, especially on the edge. And regarding, it's really good solution. And on top of what we are showing here on this example, we are also promoting the knob on display.
Yeah,
it's a rotary wheel.
So then you have a wheel right onto the display.
Yes, exactly. It's glued on the display. It's using the touch electrode that are on the display. There is no additional component needed, right? And the beauty of this solution is that it does not rely on the coupling of your hand to the display because it's using the touch on that are already existing on the display. So basically, I can use chopsticks to do the rotation. It will detect it.
Chopsticks?
Yeah.
Right.
I can use maybe something like my...
But it's nice to have something physical, but still touch screen. Everything is integrated from the one to the other.
Yeah. And the beauty of this solution is that because of the in-cell technology used, I can use, I'm using here tissue.
Which is not conductive.
Yeah, it's not conductive, and I can still detect the rotation, right? So you see I'm rotating and it's been detected. That's the beauty of the technology.
Can you say if this chipset is a ARM or what is inside the what is the architecture?
It's our own processor, which is
your own design.
Yeah, it's own design, own architecture.
Do you sell millions and millions of these?
Yes, around the world. We have
Are you one of the market leaders?
The competition is tough, but yeah, we are among the best seller in the world at the moment.
Nice.
And here, what we are selling is presenting here also is the local dimming. So the intention of the local dimming is to. So this is the new device that we are promoting at the moment. It's the SP7800. The purpose is to do local dimming. So on top of the fact that it can drive the touch and display driver IC, it can also drive the backlight, which is behind the display. So traditionally, when you have this kind of display, you have what we call the edge LED. So this is what we call full dimming. It's only the LED, the LEDs are always light on, okay? The move to the local dimming, you have plenty of LEDs behind the display, but you only light on those who are needed. So for instance, on this picture, here, you see the black content. So because it's black, you don't need to light on this LED. You only need to light on the LEDs which are there. And this is what you can achieve here. By doing this, you have a much better contrast.
Is this what they call mini LED backlight?
Yeah, kind of, because it's based on the fact that you drive LEDs, but they are not LEDs that are responsible for the pixels. It's backlight.
It's the backlight
LEDs. Right.
So you run the backlights also.
So we drive the backlight by doing so.
So you drive the backlight, the touch, the display.
And the display.
That's what's left.
Audio.
Audio. I saw something else. Yeah. And what do we see here? So that's
here we see the demonstration of the local dimming.
Yeah.
So here on this particular display, the local dimming is not on. So you see here on the side there is black, but it's not real black. If I enable now the local dimming, you will see that the black will be a very dark black. You see? Here now it's enabled. I will disable again. It's black, but it's not black. Here it's black. And this is how we achieve a very high contrast ratio.
It looks like OLED.
Yeah, but the advantage,
but
it's LCD. And the real good advantage with respect to OLED is that it's TFT, it's a well-known technology.
It's more affordable, maybe?
It's,
potentially?
Yeah, potentially, but also it's less expensive. And also in terms of aging, it's much more reliable with respect to the age compared to OLED.
The factory is very big for the LCD.
Yes.
Maybe easier
it's
to make millions and millions of them.
Exactly. It's a known technology, and although you deal with much more LED to drive,
you can do much brighter also, potentially. Brightness.
But
when you're in a car, you want to be able to see the screen.
Yeah, that's why the local dimming in the car has a lot of advantages.
All right. It's basically HDR.
It's 8-bit.
Okay.
It's 8-bit content. We only deal with we have a lot of image processing inside our device, to improve the quality of the picture in the end, together with the to drive the backlight.
Cool.
So,
All right. Thanks a lot.
You're welcome.
Cool. Maybe I can check with some of your colleagues.
David.
All right. Thanks a lot. Thank you.
Bye.
Hi.
Hello.
Hi. Please introduce yourself.
Hello, my name's David Armour. I'm head of wireless connectivity sales in Europe for Synaptics.
So what's the latest in wireless connectivity?
Well, in addition to a large range of low power, high performance Wi-Fi and Bluetooth solutions, we've just recently brought out a new family of products, which is the 4381 and 4382, one of which we've just recently won an award the last couple of days.
So here it says winner of in the wireless connectivity category.
That's correct.
So what is the product?
The product is a single chip solution that has a Wi-Fi radio. In this case, it's 2 Wi-Fi radios plus a Bluetooth 5.2 core, and also support for 802, 15.4, Thread, and Matter, all in a single chip.
One chip for all these things.
Yep.
That's special?
It is. It's very unique in a number of ways. In that a single chip allows you to create products supporting all those different protocols. In addition, the Wi-Fi radio can operate on the 2.4, 5, and 6 gigahertz bands. And this particular chip can run on 2 frequency bands at the same time. So this enables lots of really interesting applications, particularly for heavy media applications.
As I understand, Bluetooth and Wi-Fi is the same spectrum or something like that? And is Matter also over there in the same one?
Yes, it is. And part of the challenges of the radios is that where they share a frequency band, there can be interference and potentially jamming between them. So if you're doing this on a single chip, then it's needed to have some really advanced coexistence mechanisms on the radios so they work together well. We've been doing this for a very long time now, to getting really great performance while using the Wi-Fi and also streaming over Bluetooth for the audio. And it also enables us to reduce the number of antennas needed.
So is this on there, right there?
Yes.
Where's your chip? Somewhere inside?
The chip is on the small reference design that's here.
On the back side of it or something? Yeah. So it's right there. And this is a demo that's running?
It is. The demo we're running is we're demonstrating a feature we call real simultaneous dual band. So the radio is connected to the 2.4 gigahertz network for infrastructure. So we're streaming content in from the internet. And then with the other radio, we're setting up a local access point. And we're streaming that out on 6 gigahertz band to a number of small displays.
From 1 to a number of displays. And what is the protocol for that?
It's a feature that we have called RSDB. It's real simultaneous dual band. It's quite a unique feature because it's enabling us to coordinate 2 radios working at the same time on the chip, coordinating the traffic on the Wi-Fi and the Bluetooth, plus the other protocols, and also enabling a reduced number of antennas. So it makes it a very small solution and reduces the cost.
And what do you need to have running these devices? Just Wi-Fi support, and that's it?
Yeah, these are just standard little tablets connected to the 5 or the 6 gigahertz network.
You connect to the Wi-Fi network, and then
from here.
And then the app supports your protocol, and boom, you receive the signal.
Yes.
You receive the video.
So any Wi-Fi standard device can connect to our radio with fully standards compliance, interoperable, and stream and connect the data.
This app is special?
No, it's within the Synaptics software that's running on the chip.
All right. Can you describe a little bit what happens with the Matter? Why are so many people talking about Matter here, the embedded world? And why is it great to have everything and Matter on the chip?
I think the thing with Matter is where the industry's come together. 500-600 companies already, where it's enabling devices developed by different companies to be able to share data with each other in a way that they couldn't do before. So a lot of home automation systems could be siloed. For example, a garage door opener wouldn't talk to your alarm system, wouldn't talk to your heating system. Now with Matter, that data can be exchanged. And with our devices here which support this, it enables a small gateway to be made where you can aggregate that together within the smart home or the smart factory in a very, very efficient way.
some of the other standards have been, people are talking about Zigbee and stuff like that, because there was a challenge in range, or how's Matter range? Does it matter? Or?
Does it matter? Oh, okay.
Sorry.
You've been waiting all day to say that.
That's all right.
What is from a protocol point of view? Zigbee had a number of different profiles, and it was challenging to get them to interoperate in some ways. With Matter, this is where the wider industry has come together and defined a way for these devices to talk in a certified and interoperable way, which is a great step forward. It's similar in a way to the Wi-Fi Alliance, so anyone who's Wi-Fi certified, their product will talk to other devices which are Wi-Fi certified.
All right. So when we look here, does that mean when you show these very famous devices, they'll have some of your chips in there?
Yes. The bottom of the table here, the very latest generation of products that we've spoken about. These products are already shipping based upon earlier versions of our chips. Things from the DJI drone, there's a Google Nest doorbell, some tablets, and there's a wide range of other devices, particularly in IoT, wearables, where the very low power consumption of the Synaptics radios is so important.
All right. And it goes all the way down, or there's more demos over there where it says, what's happening there?
So we mentioned a BLE. So in Bluetooth 5.2 that's in our latest chips, we're adding in support for the LE audio streaming. And the demo we have here is the volume's down because it's so noisy here. But we're taking content from a video, and the video has multi-language soundtracks on it. And we're streaming that audio content out to BLE speakers. And we're doing it to two different sets of stereo speakers to demonstrate that we can do multi-language streaming, which is a feature of multi-channel streaming of LE that's so important. The great thing as well is LE is extremely low power compared to Bluetooth Classic, so enabling battery life to be way longer than before.
Yeah, they've been talking about the Bluetooth BLE, which is fantastic generation that just saves a lot of power.
Yes.
And you have it implemented in the best possible way.
Yeah, our radios actually support Bluetooth dual mode. So they have the classic Bluetooth with all the profiles which have been used for many years. And we also have the BLE radio in there as well. So we can support legacy and all the new applications on BLE.
All right, cool. So this is probably, I guess, in millions of devices out there. Your existing...
A very large number of devices, yes.
All right, cool.
Okay, thank you.
Okay, thanks a lot. And let's go around here. Hi.
Hi.
Hi. Sorry. Please introduce yourself. What do you talk about here?
Hi, yeah, I'm Vineet Ganju. I run the audio business unit in Synaptics. So what we're showing here today is a new technology we call Resonate. Resonate is a new audio amplifier technology that drives a piezo transducer, which basically allows you to use the display or any surface as a speaker. So this allows you to eliminate traditional dynamic speakers and replace it with something that's actually already part of the product, like the display in a phone, for example.
You need to put something behind that vibrates the whole thing?
Yeah, so it's a piezoelectronic material, a transducer, that's attached to the back of the display. And then there's a special amplifier technology that drives that transducer. And in this case, we're showing it attached to a phone panel, but it could be attached to the plastics or wood or any other type of surface. So
has there been some phones already that do that instead of having a little speaker, they do it through the display?
Yeah, there's been some phones that have done it, but they don't use a piezo material. They use an LRA motor. An LRA motor is typically used for haptics, to vibrate a display to get that haptic feedback. But that LRA motor doesn't give you very good audio quality. So with the piezo, it allows you to get the same audio quality, or actually better audio quality than you get with traditional speakers. But you get the benefits of a slimmer form factor. Now you can reduce the thickness because you eliminate the speaker. It's lower power consumption. You actually can get haptic feedback through the same material, so you can eliminate the LRA motor. And you don't need holes in the industrial design to allow the audio to come out. So it's naturally waterproof and dustproof as well.
There was like a phone a few years ago, and they were talking about getting rid of the bezel, and then they would not even need the speaker grill, and they would just do it through the phone.
Yeah.
But it's not as high quality. But you're going to match the quality of a real speaker.
Right, exactly. You're right. It was done in the past. You can eliminate the bezel, eliminate the speaker grill. But as I said, that was using a LRA motor technology, so it didn't get the same audio quality. With this, we can match or actually exceed the.
You exceed. You say how you exceed it because it's a bigger surface.
You can exceed because of it's a bigger surface that allows you to get a better frequency spectrum, a flatter frequency spectrum across more frequencies, and it allows you to get better perceived loudness because now the sound is coming directly at the user instead of going out of the side or out of the back.
Does it feel like your phone is a 7.1? Does it feel like you get all the different areas of the phone making different sounds, or it's just one sound source going out?
It depends on how many transducers you use. So in this case, in this case, we're using 2 transducers, so to basically sound like a stereo speakers.
Yeah, it's just a question of copyright, but for the music. That's why I
understand.
The LG has been shipping some TVs that have or Sony and LG that have it inside the display.
Yeah.
And you bring it down to any device.
Yeah. So LG and Sony have it in the TVs, as you mentioned. What our technology allows you to do is do it in smaller form factors, running off batteries. Because in this case, we're operating this at very low noise and very low power consumption. So it allows you to do it in devices like phones, tablets, PCs.
Do you always need a glass? Do you always need a display, or can you do it on like
you can attach
the plastic?
Yeah, exactly. Yeah, it's a good point.
What material do you need?
Yeah, any material that can vibrate, basically. So it can be glass, can be plastic, can be wood. Even you can imagine in a car, you can even attach it to a door panel or a dashboard.
Metals.
Metals also. If the metal can vibrate, it has to be flexible enough to vibrate.
So some kind of aluminum.
Rigid. Yeah, like an
something
aluminum,
like that.
Thin aluminum, for example. Yeah.
Can you also mix and match? Like have a little bit of glass, a little bit of metal, a little bit of plastics, and somehow they all resonate at the same time, or you have to pick where you put your resonance?
Yeah, it's theoretically possible to mix, but it depends on the properties of that particular material and how it resonates.
Do you have other demos?
So this is a sound portion of Resonate, and what this is showing is that this technology can also be used for haptics feedback. So it allows you to vibrate the screen without the audio, so that you can get that that vibration, the touch haptics response. It allows you to do force sense as well, so it can tell how hard a person is touching on the display. So if you want to do a force touch type application, if you're touching quickly or for a couple seconds, you can get a different type of response.
Is this here? It says also the winner for sensors category. Is this mass production or is it in the future?
It's sampling today. It'll be mass production later this year.
And when you talk about haptics in the phones, they have vibrations and stuff when you use a keyboard.
Right.
How does that compare the feeling of the haptics?
Yeah, so with the piezo, so today they use a motor, an LRA motor, to get that haptics feedback. In this case, you use a piezo material. You can get a much sharper, crisper haptics feedback. So it allows you to get even a better experience than what you get in the phone today.
Is it possible that you can even get the feeling of touching, for example, plastic or wood or glass, or like it vibrates in a different way? It gives you the feeling you're touching something different.
You mean if you're touching glass and it makes it feel like you're touching plastic, for example?
Or wood or something?
I don't know, actually, to be honest. I don't know. I'm not sure. We haven't actually tried that.
I don't know if that's an application.
Yeah, it's a good idea. We've never tried that, yeah. But you can shape the haptics feedback response to however you want. I mean, you're just basically playing out an audio file vibrating at certain frequencies. So.
The people that have problem seeing, they also need special haptic devices to potentially sense the surroundings.
Right.
Maybe that could be some applications too.
Yeah, exactly.
If you have more granularity in the haptic feedback.
Yeah, you can have more granularity of both cases, either how hard you're touching or for how long you're touching, as well as the feedback, like you said. It could be a short pulse or a long pulse.
And it's the same device that does the sound and the haptic feedback?
Correct, yeah, same device that does both.
It's just different
frequency range that is playing back the audio out of.
Right. You get better bass, or
No, you don't get better bass with piezo. You get a better, flatter frequency response across all the frequency band, but you won't get a louder bass necessarily. The bass has to do with the size of the material itself.
could you also combine it with regular speakers?
Yeah, absolutely. Yeah. So if you want a better bass or a louder bass, then you can combine it with a subwoofer or a low frequency traditional dynamic speaker and mix the two.
And get kind of like a home theater experience from a little device.
Yeah.
Something like that.
Yeah, exactly. You can get a 5.1 or 7.1 type of experience.
Cool. All right.
Yeah.
Thanks a lot.
Thank you.
Thank you. Cool. Let's go around right here. All right. Hey. 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 How are you?
Good.
Please introduce yourself.
Hi, I'm Siddharth Chandrasekhar. I'm Senior Director of Marketing for our multimedia SoCs. We're showcasing here a bunch of solutions in SoCs. Actually, let's
What's
start
your
over here.
SoC? Is that the big one there?
Yes, that's the evaluation kit.
It's there?
Yes.
So you make the big chip?
No, that's the heat sink. So it's
sorry.
actually something like this.
There.
That's the chip.
So can you explain? What are we seeing here?
So this is actually a system on module. So you'll have the chip plus the memory and a few things. So that you get a small system on module. This is the kind of form factor you fit it in. This is a kind of similar to Banana Pi. So it's actually, Raspberry Pi. We call it Banana Pi. So it's based on 680. So it's fully functional.
Is it an ARM?
This is Quad A73, ARM Quad A73 with a GPU and a powerful NPU. So like nearly 7 tops NPU.
That's powerful.
That's very powerful, and that's why you can see all this complex AI use cases that you can do. So here is doing full body pose estimation of all the people. That's a different use case where you can see based on depth. So this camera is just a single camera. It doesn't have stereoscopic, but based on kind of depth, it is choosing what's the foreground, what's the background, and blurring it out.
Nice.
There are all sorts of kind of use cases that we're doing.
Has Synaptics been doing ARM SoCs for a long time?
Yes, so actually this dates back to the acquisition of Marvell's multimedia SoCs. They've been doing it since the early 2010s. We've continued doing it. We acquired it in 2017, so we are actually on our 6th generation now, which is the 680 and the 640. That's what you're seeing. And our main key differentiator outside of the full video decode and display pipeline is the AI capabilities.
And when you see this Banana Pi right there, is there a big community? If you can grab, let's grab it right here. Yeah. Is it this one? Is there a big community developers?
So this has just been kind of launched, so it's still in the ramp phase. But there is a different version of the Banana Pi, which is more or less the same thing. This is actually a Baidu Pi.
Let me just come right here. So Baidu Pi.
Yes, Baidu, which is obviously Baidu is like, it's the same chip, the 680, but all of Baidu's AI models have been ported there. It's being distributed across all sorts of universities in China.
96 boards, or is the form factor is just similar to a Raspberry
Similar
Pi?
to a Raspberry Pi, exactly.
Yeah.
So it's a different version of, it's a slightly different because it's designed by Baidu.
And it's got the same ARM Cortex A73 and everything?
That's correct.
And A55?
It's the same basic, the A55 is the 640.
On the big one, you also have small cores?
No,
only big.
Only big.
But the big is scalable. It's still not using too much power.
Scalable. Everything can be turned on and off individually. The other advantage of our AI engine is it's fully within the trusted execution environment. So it's fully secure. Nobody can ever touch the data or the model, as well as you can operate models on any type of content. So think of in like a set-top box world, an operator has launched a service where you can run object detection on any content, whether it's broadcast, YouTube, Netflix, Amazon, doesn't matter, because you're never breaking any of the DRM or security protocols.
Here's asking, what's the package called? So what's the platform? What's it called?
So this is called Banana Pi.
Yeah.
Our actual SoC is the VS680, which is the Quad A73. And the lower end device is VS640, which is Quad A55. And both have NPU engines. The NPU on the 680 is 7 tops. NPU on the 640 is 1.5 tops.
Are you in many, like when I see this kind of device, it will be inside?
Yep, this is a set-top box. This is actually like a splitter, video splitter or video wall device. Can take 6 inputs and output 1, 680 powering that. This is like an enterprise video conferencing device.
It might even be 4K or...
We are in smart displays, we are in appliances. So again, combination of using the display and video, but also the AI to make decisions about temperature, ingredients, and the camera and stuff like that.
So it comes from the Marvel Armada stuff
That is exactly
before?
That is exactly right.
But
So it's an
there's a
evolution.
part of that goes in a different market that stays in Marvel?
That's correct.
And you have
We
that.
took the video side of it. Basically, the multimedia processors has come over to Synaptics.
And how good are your video processors? You can do 8K,
So
4K?
no, the 680 can decode 2 4K P60 simultaneously, or many more lower resolution. The 640 can do 1 4K P60 plus 1 1080 P60.
Do you have a lot of partners working on different projects with this?
Yes, so both products are already in mass production, shipping in millions of units today.
Millions?
Yes.
And what do we see here? Can you hold this?
Yeah.
What are these different boards?
Yes, this base, just different boards with different connectivity options.
And they're all using the same chip?
All using the same chip.
And there's a bigger one there.
Correct.
And this one is more for like development, or?
This is, I think, meant for more the kind of video soundbar that you see. So supporting dual camera and even more interfaces going out.
Do you support Linux?
Linux and in 2 flavors, both Ubuntu and Yocto, as well as Android AOSP, but also Android TV flavor because of the...
What kind of customers do the Ubuntu and the Yocto? What do they use it for?
Like the appliance or security. So mainly in the industrial space, it's mainly Yocto. In the consumer space, it's primarily Android. Then in this kind of enterprise space, it's a mix. Some are Android, some are... You also have like smaller... We also have video phones, IP phones, that instead of just audio, they also support video. Those are also Android-based, but the simpler ones can be Yocto.
And here, when I look here, is it this one?
This is just using as one of the inputs for this splitter. So because this can take 6 inputs, so if I show this, so you can see I can kind of show 6 inputs at one time. So we've got 6 inputs coming in, 2 from that camera you see there. 1 is the AI demo running off the Baidu board, and 3 are just like set-top boxes that have been plugged in there.
What do we see here? Is that a Raspberry Pi?
Yeah.
Running it, so it's not one of your boards?
Not one of ours.
All right.
It's just using to power this demo.
All right. So lots of projects happening at the embedded world.
Absolutely.
Lots of advancements?
Yes, and part of what we're doing here is that we've got some of these SOMs, but we're looking for more partners to build some other variants and extending our ecosystem of partners here.
Cool. All right. Thanks a lot.
Thank you very much.
Thank you. All right. Okay. And go around right here.
2 business models.
All right. Let's finish the bus tour. Hi.
Hello. Hi.
Hello. Please introduce yourself.
So I'm Elad Baram, and I'm running the marketing here in Synaptics for the low-power vision AI.
So I see this stuff there.
Yeah,
Are you in there?
This stuff there is it's an edge SoC. It's named Katana. The defining factor here is power. So it's a very, very low power processor. It has an M33 ARM core, high-frequency 3 DSP, and a tiny NPU. And it's actually a microcontroller that is capable of both vision AI and audio AI.
Vision and audio AI. What audio AI does it do?
So it can do sound event detection and things like that. Here in this demo, it's actually showing all the vision capabilities. So on the here the TV just turn off. Here it's showing human detection models. This is targeting actually like a smart human sensor. So application like battery operated device. So today they are all activated by a motion sensor. but now we want to augment the capability and actually keep them as a battery-operated device, but say, hey, this is not just emotion. We are seeing a face, we are seeing a person, we are seeing a car, we are seeing a dog. So having something which is more...
and it's very low power.
This one is working on just a few tens of milliwatt when it's on active and on microwatt when it's not. So
it sounds crazy.
It sounds
it's
crazy.
Much lower than a security camera power consumption.
A regular camera, you would take about 1 watt when it's working on active. So this is like
using 1,000 times less.
We are about 1/10.
100 times less.
Yeah, something like that. Yeah, this is the.
It's just a small part of a security camera.
Yeah, you can use it as a small part as a security camera if you want the security camera to be always on, or you just can make it as a standalone sensor, like a smart sensor, and use it something that would sense the environment and then can send the metadata to the control panel saying, hey, we are seeing there was some motion here, we are seeing a person, you should take care of that, and not necessarily send image out because sometimes privacy is a concern. So one of the advantages of having those analysis on the edge is that you don't need to send the image out in order to do the inference. So everything is happening on device.
All right. And this mass production is available?
Yeah, this is available.
It's brand new?
In mass production. It's been a while. We have a few designs going on. Yeah, it's pretty exciting.
Cool. All right.
And that's here in the other one, this showing face detection. So this is a little bit different use case. It's actually, so there is a new category which we call an HPD, human presence detection. Sometimes it's actually user presence detection, which the idea here is not for the security market, but actually to make consumer electronics smarter and actually to understand whether there is a user or there is no user. So in example, in the laptop case, this is being used for the system to know if the user is engaged with the content or not engaged. If it's not engaged, it will dim the screen, it can save a lot of power. When you walk away, it will automatically turn off and will lock and so on. And we believe that a laptop is the only first instance of this type of context awareness, and now it's starting to go to other consumer devices that can have the same benefits.
Cool. All right. Thanks a lot. Thank you.
Thank you.